Friends, good morning to everyone. We were dealing with various source of impurities, types of impurities, along with the controlling process of the impurities. As we know that impurities cannot be controlled completely 100%. However, it can be controlled and it can be kept in limit. And what are these process which we use for controlling this limit within the limits or within the permissible limits were discussed in the last presentation. In continuation of that, we can look into the various methods used for controlling the impurities. Any process defects in the manufacturing may lead to impurities, and that is the another source of impurity. Hence, how to control this thing? What are these defects in the process of manufacturing? This may include improper or inadequate conditions of maintenance of temperature, pressure, or pH, or any other reaction conditions. Like if the reaction has to be carried out under inert reaction conditions, if that inert conditions cannot be maintained, then it is an imperfect maintenance of the reaction conditions. Or it should be mixed properly while carrying out the reaction. If that mixing is not perfect, then it gives rise to imperfect mixing, and which makes the incomplete conversion of the starting material to the product, which all leads to incomplete reaction and not complete conversion of the starting material to the product. That's why, in order to how to control these, maintaining the proper reaction conditions required for the reaction to occur. Like I can give an example. In the process of manufacturing of zinc oxide, we take metallic zinc and heat it to bright redness in a current of air. Then the zinc metal reacts with the oxygen under very high temperature to give rise to zinc oxide. If they in this process the zinc burns to form zinc oxide. Zinc oxide is a white fine powder. When the metallic zinc is not heated complete at the temperature required, and if the air which we supply when heating is not up to the mark, or any of these things or both together may not convert the total zinc present in the reaction mixture to zinc oxide, then what happens? As it along with zinc oxide, when we take it, the unreacted zinc also exists along with zinc oxide. The zinc, the starting material, can act as a source of impurity in the zinc oxide. Thus, what we should do to avoid, we have to maintain the proper reaction conditions. Maintaining the proper reaction conditions like proper temperature, pressure, pH of the reaction, mixing of the reaction in efficient manner, or any other reaction conditions like inert atmosphere, anything required is not maintained, then that all causes the defects in the manufacturing. One method is to to completely maintain the reaction conditions required for the reaction to occur. If at all by chance it is not maintained, then it gives rise to impurities like the unreacted metallic zinc will be present in zinc oxide. How to control that? We have to test whether any zinc is present in the zinc oxide. That's why Indian Pharmacopoeia prescribe the test for zinc metal in zinc oxide. If the test gives positive, then the zinc metal is present and that cannot be used when it is present in more than the prescribed limit. We may not be able to completely eliminate the zinc metal because how much ever we do the reaction conditions because of human errors or the manufacturing errors, some amount of metallic zinc may be present in zinc oxide, but if it is within the limit of as prescribed by Indian Pharmacopoeia, it can be used. The raw materials which we use plays a very important role, the purity of that raw material, and also the process of manufacturing is also equally important. Hence, in the manufacturing process we have to do the assurance of quality, whether this reaction temperature is maintained properly or the pressure required or any other conditions. We are assuring the quality at each and every step of the reaction process or even each and every step of the formulation process. If we take the formulation process, good mixing of all the ingredients is very much required. And during the process of granulation in the preparation of the tablets, the granulation should be of proper size, proper thing, and that can be achieved by adding the perfect amount of the granulating material and also the mixing process. Everything plays an important role. At each and every step, we assure the quality of the product, and then we can control this defects in the manufacturing process so that the final product is in either the active pharmaceutical ingredient or the formulation which we have prepared is devoid of any impurities. Hence, not only the manufacturing process and assurance of the manufacturing process for its effectiveness is also equally important in the preparation of pharmaceutical products. Another source of impurity is the intermediates which are formed in the reaction process. If it is not completely converted, then that can also act as an impurity. Many processes includes intermediates, and if it is carried to the final product, that will be the source of impurity. I can give an example of preparation of potassium iodide. Potassium iodide is prepared by reacting iodine with potassium hydroxide. When we react 6 moles of potassium hydroxide with 3 moles of iodine, it gives rise to 5 moles of potassium iodide and 1 mole of potassium iodide and 3 moles of water. Though major product is potassium iodide, there is an intermediate which is formed, that is potassium iodate. Though it is a byproduct, this byproduct is again converted into potassium iodide. The reaction mixture contains potassium iodide, potassium iodate and water. First we evaporate this resulting solution of the reaction mixture. The water gets evaporated and the reaction mixture contains potassium iodide and potassium iodate. And this potassium iodate which is formed, when we take this reaction mixture, When you heat it, we heat it with charcoal. When you heat this reaction mixture containing potassium iodide and potassium iodate with charcoal, charcoal is the source of carbon. This carbon present in the charcoal reacts potassium iodate, and it gives rise to potassium iodide and carbon monoxide. Whatever potassium iodide formed will get converted into potassium iodide. Hence, if this conversion is not done completely, potassium iodide can be a source of impurity in potassium iodide. That's why we have to ensure that complete conversion of potassium iodide takes place in the reaction process. This potassium iodide is an intermediate product which is formed during the process of potassium iodide manufacturing or preparation, and this care should be taken to completely convert its potassium iodide by efficient reaction of potassium iodide with charcoal, thus making the reaction condition to completely occur is one of the methods of controlling this impurity that occurs in potassium iodide. Other sources of impurities are manufacturing hazards. The manufacturing hazards includes particulate contamination, contamination by the particulates, cross contamination. When you are manufacturing 3 4 formulations or active pharmaceutical ingredients in a single unit, one may contaminate the other. The errors in the process of manufacturing, and if they are liquid preparation, the microbial contamination can also occur during the process of manufacturing or during the storage conditions. And if there are any errors in the packaging of the prepared final products, that may lead to manufacturing hazards. These are the 5 types of manufacturing hazards which acts as the sources of impurities. That's how to control this. When we keep it under control, this can be avoided. Let us look into the particulate contamination. What is this particulate contamination? These are the unwanted particulate matter that arises in the form of dirt or dust or glass or porcelain pieces or plastic fragments which get eroded in the from the sieves, the granulating equipment, or the tableting machine, or from the containers from which in which the product is stored. Hence, the proper storage conditions and proper reaction conditions is a must to avoid this particulate contamination. This occurs due to the wear and tear of the equipment. When we use the equipment continuously, it gets wear and tear. And along with this equipment should be properly maintained, and it should be replaced if it is not in the proper conditions. By taking care of this, we can control the particulate contamination. And after each and every use, we have to clean the equipment in a proper manner and ensure that it has been cleaned, because improper cleaning of the equipment is another source of the particulate contamination. The method of controlling is proper cleaning and proper maintenance of the equipment used in the manufacturing process. Otherwise, it may lead to hazards in the manufacturing process. In case of injections, the clarity of solution test for clarity of solution is carried out. Each and every ampule of injection which has been prepared is tested for any particulate matter that is present against the bright light and the white background. If anything is there, we will discard it. In case of packaging materials, what we use, the metal particles from the container can get into the active pharmaceutical ingredient or in the formulation preparation. The eye ointment, if we store in the metallic tubes, the metallic particles of the metal tubes can get into the ointment which we have prepared. That's why we avoid the ointments packaged in metallic tubes. The terramycin which has been prepared and stored in the metallic tube, the erosion of the metallic particles into terramycin, which is eye ointment, and this when it is used, instead of curing the problem, it creates a new problem. That's why it should the metallic particles, what that's why what we should do, the eye this particular ointments should not be stored in metallic tubes. The cross contamination occurs by handling various processes or preparing various different types of compounds in the single manufacturing setup, and the dust or dirt arising from the powders or granules or tablets in the bulk manufacturing, one ingredient can contaminate the other ingredient. This leads to cross contamination. And how to control it? By using a special extraction equipment. Above the mixing, when we carry out mixing of various ingredients in the tablet manufacturing process or in the granulating process, it creates dust or dirt, and that should be removed from the processing area. By special extraction equipment, we can remove it, and that's why we can avoid cross contamination. And not only the product contamination, we have to protect the operators by the contamination. Hence, the face masks should be used by the operators to protect themselves from the harmful side effects of the drugs. Penicillin preparation requires a special handling during the process of its manufacturing. The cross contamination can arise from the contamination from the products from the environment and the environment from the environment and the apparatus, products from the equipment. The contamination can also be from contaminates from the environment and apparatus, contaminates from the equipment. Both contamination and cross contamination are the hazards in the manufacturing process. Care should be taken that this type of contamination should not occur, so that the impurities in the final products are controlled. The microbial contamination is another source of impurity, especially in the parenteral and ophthalmic preparations. Care should be taken that microbial contamination should not occur during the process of manufacturing and during the process of storage. The liquid preparations and creams are the most liable for bacterial and fungal contamination. Hence, when you use the acacia, senna, or tragacanth gum in the liquid preparations of the creams which are used for parenteral and ophthalmic purpose, should be controlled for salmonella infection, microbial contamination. Or whenever possible, it should be our usage of these gums should be avoided. This is how we can control the microbial contamination. The packaging errors is another source of impurity. Many products what we prepare may have similar size, shape, color and packing material. Then one tablet may get packed in the other container. Then cross errors occurs because of this package error in the packaging. And this is the potential source of dangers. That's why it should be segregated properly. And by segregation of from the tablets to the packing material will be the method of controlling of this packaging error. If there is any contamination occurred or any wrong thing occurred, then what we should do? We should completely distract the total packed material. The unused labels should be destroyed so that the packaging errors can be avoided. We should do one at a time, or we should completely segregate the one product from the other product, and in a completely different setup packaging should be done. That's why that's how we can avoid the errors and control the dangerous effect by using the wrong medication. The errors in the process of manufacturing, that is in the process of preparation, liquid preparation, it can occur, and where is incomplete formation of the solution or suspension or an emulsion will lead to the impure products. Then this can be detected by analytical control procedure at each and every step. That is the way of controlling any discrepancies in the manufacturing process. Minor errors in the manufacturing process can lead to improper active ingredient in the product and improper quantity, then it gives to the source of impurity, and that should be avoided. Quality assuring at each and every step is the method of controlling the process errors so that impurities do not arise in the final product.